In this lesson, we're going to talk about how to rationalize the denominator, which is always fun to show off how smart you are and say, I know how to rationalize the denominator. Seems pretty impressive. Here's how we're going to do that. First, we're going to talk about what it means to simplify a radical. Then we're going to look at the steps to rationalize a denominator. And then we're going to simplify a radical in a fraction. What does it mean to simplify a radical? Simplifying a radical means to write an equivalent radical. It's going to have the same value if you put it in your calculator, but the simplified radical will have no perfect squares in the radicand, and it will have no radicals in the denominator of a fraction. The phrase rationalizing the denominator means we're going to make the denominator, the bottom of the fraction, rational, which means it's going to be just an integer, not anything, no weird square roots in it. Let's look at the steps on how to do that. So here we have simplify the square root of 49 over 2. And before we look at the steps, we can write this as the square root of 49 over the square root of 2. Just so you know, we can split that square root. It goes all the way to the bottom of the square root. So it's like I have the square root of the numerator and the square root of the denominator. Okay, so step one says, check to see if there are perfect squares that can be simplified. Ha-ha! If you type the square root of 49 in your calculator, you get 7. And sometimes you get super lucky and the square root of this number is also a perfect square. It's already a perfect square, and so then you're done. Like if this was the square root of 4, for example, and we still have the square root of 49 up here, we'd have 7 over 2 and we're done, okay? Don't have that this way in this case. All right, so number 2, this is pretty slick. How you do this. You multiply the numerator and denominator by the denominator. Basically, we force a perfect square to be in the bottom. Okay, so here's my problem, 7 over square root of 2. The same thing as this if I type it in the calculator. It's still going to be the same thing when I multiply it by the square root of 2 over square root of 2, because even though that's really big, it really is just the same thing as 1. I'm just multiplying this by 1. So I'm not really changing the value of it, I'm just changing the way it looks. And I'm forcing a perfect square to be here in the bottom. So I get 7 over the square root of 2. And then the square root of 2 times the square root of 2 is the square root of 2 squared. So I have a perfect square now. And the square root of 2 squared is just plain 2 with no more square root. And I've done it. I know that this doesn't look any more simple than this. But remember, the goal was 1, no perfect squares in the radicand, and we don't have any perfect squares, it's just 2, that's a prime number. And number 2, no square roots in the denominator, and we don't have that. So this is the definition of simplified, and we're done. Let's look at one more example. Simplify 5 over the square root of 98. So check to see if there's perfect squares that can be simplified. Well, the square root of 98 it's not a perfect square in itself, but I think I see a perfect square hiding in there. Oh, there it is. Let's do it all the way out with our factor ladders. So the square root of 98 is the square root of 2 times 7 squared. And the square root of 2, I can't take the square root of that, but the square root of 7 squared is just 7. Okay, so I did that. I checked to see if there were perfect squares that could be simplified, and I did that. This was step 1. Step 2, I'm going to multiply the numerator and the denominator by the denominator, but I'm just going to multiply it by the square root part, not the whole 7 square roots of 2, because I just need to get rid of the square root of 2, not the 7. The 7's fine. He's fine where he is. I'm just going to rewrite it so you can see that this is the second step here. And so then this is 5 square roots of 2 over 7. Square root of 2 times the square root of 2 is the square root of 2 squared times 7, still out there. And the square root of 2 squared is just 2. And this is all multiplication. Notice in this whole problem, nowhere do I have a plus or a minus or anything like that. It's all multiplication and it stays multiplication. So my answer is 5 square roots of 2 over 14. And if I divide that in my calculator and I divide this in my calculator, I should get the same thing. And it's simplified because there are no perfect squares under the radicand and there's no square root in the denominator.